This is about taking a few examples on resonance. Let us take example number 1 for the day, which is based on parallel resonance. So you have R, L, C. You have R, L, and C. Right? It is given that this particular circuit resonates at omega naught equals to 1000 radians per second. So the resonant frequency is given, and at resonance, it is given that the impedance, or I should say the driving point impedance at resonance, is equals to 10 raised to the power 5 ohms. Okay. Another thing which is given is that the bandwidth, which is omega h minus omega l, which can be written as bandwidth, is equals to 100 radians per second. Okay, a few things are given. That your circuit is a parallel RLC type of circuit which resonates at frequency 1000 radians per second, having bandwidth equals to 100 radian per second, and the impedance at resonance is equals to 10 raised to the power 5. And what you have to do is you have to determine what is R, what is L, what is C. 3 conditions are given and 3 unknowns are to be determined. Okay, so I assume that you are well equipped with the revision and the formulas which can be used for resonance analysis. So it is very simple from here. Can any one of you tell me, anyways, if you would take the admittance representation also of this particular RLC circuit, so you would take that admittance is equals to 1 upon R plus 1 upon j omega L plus j omega C. I hope you would all agree to with this particular notation. But you see that these two terms are actually going to be imaginary, and at resonance, what happens to the impedance or admittance? The imaginary term goes to 0. Therefore, at resonance, our impedance should be purely real, and that means it should only be equals to R. So if it is given that at resonance your impedance is equals to 10 raised to the power 5 ohms, it means it is given that your R is equals to 10 raised to the power 5 ohms. The logical reasoning से एक unknown हमें पता चल गया, and what that is, it is that at resonance, because the impedances are supposed to be only and only real, the imaginary part should vanish. So R is 10 raised to the power 5 ohms. Fine. Another thing is, what is the relationship between omega naught and LC? Can anyone tell me what is omega naught is equals to in terms of L and C?
1 upon under root LC.
Exactly, it is 1 upon under root LC. But you know that omega is known, but we are unaware of L and C. तो ये डायरेक्टली हम यूज नहीं कर सकते. एक पहली थॉट आई जरूर थी कि जो रिलेशनशिप है ओमेगा नॉट और एलसी में, इफ इट कैन बी यूटिलाइज्ड, बट द थिंग इज नो, यू कैन नॉट यूज दैट. Okay, so we will now look at and search for what are the other conditions given, and the condition given is bandwidth, and we can utilize bandwidth. Okay, fine. So let me first tell you that for such type of circuits in which you have R, L, and C all in parallel, your quality factor is equals to, what is the value of quality factor? Omega R C. Okay, it is equals to omega R C because it is equals to resistance upon reactance. अगर मैं C वाला कंसीडर करूं, otherwise it would be R upon omega L. It is resistance upon reactance, और यहाँ पे I should be saying omega naught RC. This is quality factor. Fine. But you should also be knowing that quality factor in terms of resonant frequency and wavelength is, what is the formula? In terms of resonant frequency and wavelength, it is not wavelength but bandwidth. The resonant frequency and bandwidth. So it is resonant frequency upon bandwidth. So it is omega h minus omega L. Fine. So this is quality factor, which is omega naught into C into R. So we will use this particular formula, that quality factor, which is equals to omega naught upon omega H minus omega L, or I can say that quality factor is equals to resonant frequency upon bandwidth, and this is equals to omega naught R into C. ठीक है, ये जो जनरल टेबल आपको बनवाई थी आप उससे देख सकते हैं. Now you use your formulas over there. So omega naught here cancels, and you get that 1 upon CR is equals to bandwidth. So you can write that 1 upon C is equals to resistance times bandwidth. Bandwidth is equals to omega H minus omega L. और ये पूरा का पूरा term ही दिया गया है आपको. केवल bandwidth mention है, you know that the whole term is given then. So it means that 1 upon C is equals to R into, what is the bandwidth given?
100 radians per second.
100 radians per second. So it would be equals to 1 upon C. R is 10 to the power 5. R is 10 to the power 5 into 100 radians per second. तो ये हो गया 10 to the power 5 ohms था, तो ohms into radians per second, तो omega into J वाला term आ गया. So it gives you the value of capacitance, and that would be equals to 1 upon 10 raised to the power 7 is your capacitance in farads. Okay, 1 upon 10 raised to the power 7 farads. So I can write it as microfarads में कितना हो गया? So it would be 10 raised to the power minus 7 farads. So I can write it as 1 upon 10 into 10 raised to the power minus 6 farads. 10 raised to the power minus 6 is 1 microfarad. So it is 1 upon 10 microfarads. So it is 0.1 microfarads. So now we got to know about capacitance as well. Now you can use अब inductor निकालना है या inductance निकालना है, वो कैसे निकालें? C known है, so you can use any of the things like omega naught is equals to 1 upon under root of L into C. So from here you can use the fact that omega naught square into C should be equals to 1 upon L, or L should be equals to 1 upon omega naught square into C. So L would be equals to, then it would be 10 raised to the power 6 into 10 raised to the power minus 7. तो बताएं L कितना हो जाएगा? It would be minus 6 minus 1 upon 10 raised to the power minus 1 is 10 raised to the power plus 1, which is 10 henries. So you have now determined everything which was needed. So you have actually found what is the value of resistance. You have found what is going to be the value of capacitance as well as inductance. And this was the thing which you were supposed to find out. Okay. So this is how you are going to solve if examples or questions are asked based on such applications of formulas. But would you be able to do this? Yes, you should be, provided you are well equipped with the formulas and the theory which is being taught to you in class. Another example is quite tricky, but those of you are were very attentive while watching videos or in live class would be able to solve it. So the question now goes something like this. Okay, and the values are 10 ohms, 0.1 henries, 100 microfarads, 100 ohms, and this is E angle 0. This is E angle 0, and what they have asked is this: find out what is the resonant frequency. Resonant frequency. Resonant frequency निकाल. How would you do that? So resonance occurs when this supply voltage and this supply current, let's say I, are in phase. And when they will be in phase? If the imaginary part of the net impedance of this particular portion, like यहाँ से यहाँ तक का net impedance का imaginary part क्या हो जाए? Zero.
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 So we will utilize that fact only. So we will not look at कि ये e क्यों नहीं दिया था, इसकी value क्या थी, because we know that as far as you can make the imaginary part of the net impedance over here 0, you can get the conditions of resonance. Fine. Then here what you have to do is, so आप बताएं कि अब ये net impedance किसके बराबर होगा. तो Z, which is going to be the net impedance, will be equals to 10 ohms plus j omega L. Omega नहीं पता है, but you can write as j into omega into 0.1. Okay, j into omega into 0.1. You can write it like this. Plus the equivalent resistance of these two in parallel, which means the resistance which you will be getting after finding out the equivalent of 1 upon j omega into 100 microfarads. और फिर इसका इमेजिनरी पार्ट निकालना होगा, उसको 0 के बराबर करना. तो पहले तो इसका इमेजिनरी पार्ट ही निकालना है. Fine. So the only trick is to find out the equivalent of this thing, and that we are going to do. If two resistances are connected in parallel, for example, एक R1 ये रहा, एक R2 ये रहा, इनका net equivalent resistance क्या होता है? What is R equivalent of such cases? बताएं.
R1 R2 upon R1 plus R2.
Exactly, and this is what we are going to use. So इसका जो equivalent होगा, it would be equals to, देखें यहां से मैं आपको बता देना चाहता हूं कि ये जो हमारा Z1 होगा इसमें, इट लेट्स से 100 ohms, और जो Z2 होगा इट विल बी इक्वल्स टू, क्योंकि ये माइक्रोफैरेड्स में है तो आई कैन राइट इट एज 1 अपॉन j ओमेगा 100 इंटू 10⁻⁻⁶. तो फिर हम इसे ऐसे लिख सकते हैं, बिकॉज इट इज 100 इंटू 10⁻⁻⁶, तो नीचे बचा 10⁻⁴, तो ऊपर आ गया 10⁻⁴ अपॉन j ओमेगा. ये भी ओम्स में है, जब j ओमेगा लगा देते हैं तो ओम्स में बन जाता है, फेरेड्स में नहीं रहता है. सो Z1 इज 100 ohms, Z2 इज 10⁻⁴ अपॉन j ओमेगा. तो Z इक्विवेलेंट क्या हो जाएगा इस पैरेलल चीज का? इट वुड बी 100 इंटू 10⁻⁴ अपॉन j ओमेगा डिवाइडेड बाय 100 प्लस 10⁻⁴ अपॉन j ओमेगा. ओके, राइट दिस डाउन. सो ये इक्विवेलेंट रेजिस्टेंस यहां पुट करें तो नेट Z जो हो गया हमारा, इट वुड बी 10 प्लस 0.1 j ओमेगा प्लस it would be 100 into 10⁻⁴ upon j omega divided by 100 plus 10⁻⁴ upon j omega. Just like this. Okay. It's going to be like this. थोड़ा सा और इसे सॉल्व करें, you will get Z is equals to 10 plus 0.1 j omega plus, okay, it is going to be now 10⁻⁶. Okay, so this is 100 and this is going to be 10⁻⁶. Fine. (10⁻⁶) माइनस साइन अपॉन इंटू j अपॉन ओमेगा. माइनस साइन लिख के यहाँ j लिख सकते हैं, अपॉन 100 माइनस 10⁻⁴ j अपॉन ओमेगा. अब इसे आप रैशनलाइज करें, इस टर्म को रैशनलाइज करें. इट वुड बी Z इज इक्वल्स टू 10 plus 0.1 j omega फिर माइनस 10⁻⁶ j अपॉन ओमेगा डिवाइडेड बाय 100 का स्क्वायर प्लस 10⁴ अपॉन ओमेगा का स्क्वायर और मल्टीप्लाई करेंगे आप 100 प्लस 10⁴ अपॉन ओमेगा इंटू j से. ओके, आर यू फॉलोइंग? यहाँ तक ठीक है? एनी मिस्टेक्स, एनी प्रॉब्लम, एनी इश्यूज?
No, sir.
ओके, अब यहाँ से when you will multiply these things inside, what we need is this, that the imaginary part हम लोग एक साइड लिख लें और जो नॉन इमेजिनरी पार्ट है उसको हटा दें. तो let us take out the imaginary part out of z. So z is equals to 10 plus 0.1 j omega, or it's going to be something like minus 10 raised to the power 6 into 100 j upon omega upon 100 square plus 10 raised to the power 4 upon omega का स्क्वायर. ओके, और फिर आएगा माइनस माइनस प्लस, it would be 10 raised to the power 6 into 10 raised to the power 4 upon omega upon 100 का स्क्वायर प्लस 10 raised to the power 4 अपॉन ओमेगा का स्क्वायर. बट दिस इज रियल टर्म, दिस इज रियल टाइम. अब इसमें से जो इमेजिनरी पार्ट दिख रहा है मुझे, इट इज ओनली दिस. ओके, गॉट इट? यू सी ओनली द इमेजिनरी पार्ट. प्लीज चेक देयर शुड नॉट बी एनी मैथमेटिकल मिस्टेक. अगर है तो बता दीजिए, यू कैन पॉइंट दैट आउट फ्रॉम प्रीवियस पेजेस इफ देयर इज एनी. So the imaginary part of z is to be made 0. It means हम यहाँ से ऐसे लिख सकते हैं that 0.1 into omega, अब देखिए j तो हम हटा सकते हैं, should be equals to 10 raised to the power 6 into 100 upon omega upon 100 square plus 10 raised to the power 4 upon omega का square. अब इस पूरे को आप solve करें. Okay, so what it would become? It would become something like this. You have 0.1 into omega, which is to be multiplied with 100 ka square plus 10 raised to the power 4 upon omega ka square, and then it is be written equal to 10 raised to the power 8 upon omega. Correct? That's how you would do it. Further open कीजिए brackets को और solve करने की कोशिश करें. So I can open the bracket now. It is 100 square is 10 raised to the power 4. Fine. Plus 10 raised to the power 8 upon omega square, which is to be multiplied with 0.1 times omega, which is equals to 10 raised to the power 8 upon omega. So you see that it becomes equals to 0.1 times 10 raised to the power 4 plus 10 raised to the power 8 upon omega square, which is equals to 10 raised to the power 8 upon omega square now. Okay, see, ये जो ओमेगा है उसको मैं डिनोमिनेटर में ले जाता हूँ. फिर ये बचेगा 10 raised to the power 3 प्लस 10 raised to the power 7 upon omega square. ये 8 है, 0.1 से मल्टीप्लाई होके 7, 10 raised to the power 8 upon omega square. आपके पास बचेगा 10 raised to the power 3 is equals to 10 raised to the power 8 upon omega square minus 10 raised to the power 7 upon omega square, taking 1 upon omega square common, and 10 raised to the power 7 common, you would have 10 minus 1 there. Right? Correct? So that's how it is. And from here, if you would find out what is going to be omega square, then you can write it as 10 raised to the power 7 into 9 upon 10 raised to the power 3. Then omega square is equals to, okay, 10 raised to the power 4 into 9. Am I right? And omega is equals to 3 into 10 raised to the power 2, which is equals to 300. वो माइनस वाला तो नेग्लेक्ट करना होगा. There is nothing like minus of a frequency. So positive frequency you would take it is equals to 300. Units would be what?
Radian per second.
Radians per second. Okay. And that is how you are going to solve such questions. Mathematically tricky, but you know that the fundamental requirement was only very small, that you have to make the imaginary part of the impedance or the driving point impedance to be equals to 0, so that the driving point voltage and the driving point current are in phase. That's it. That's what resonance requires. Okay. But you have to be really attentive and calculations में गलती नहीं होनी चाहिए. When like when I was preparing for the class, I was getting confused somewhere in solving this question, and when I solved it 2 times or 3 times, every time I was solving, I was getting a different answer. But when I taught it in last few years, I knew it that the answer is going to be 300 radians per second, but somehow because of some issues in calculations or all, I was getting different answers. But 300 radians per second is the only correct answer. अब ये असिस्टेड था, आपने मेरी हेल्प की, मैंने आपकी हेल्प की, तो ये सही आंसर तक एक ही बार में हम पहुंच गए. एंड देयर वाज नो सच मिस्टेक. दैट्स व्हाई आई वाज वेरी कॉन्शियस. बता दीजिए कहीं गलती तो नहीं हो रही है. अगर आप खुद से करेंगे पहली बार, हो सकता है you might make mistake, but if you will be attentive, you will not make mistakes then. Okay, so this is the example which I wanted to cover. There is another interesting example, and I think that we can take as a different recording. So for that, I would stop this recording